Now, in this video, we will going to take up one more problem on projections of lines by the problem number 67 and how to solve this by using three-dimensional analysis and also by using the sketchball. The problem reads as a point capital P is 40 mm above HP and 20 mm in front of VP. Another point capital Q is 20 mm above HP and 50 mm in front of VP. The top view of line capital PQ is inclined at 30 degrees to XY line. Draw its projections. So first, when you look from the front view, we can see the point P is 40 mm above HP. So when you look from the front view, the distance point P, which is above HP, 540 mm, and when it is projected, that is projected onto the vertical plane. So this is the distance 40 mm above HP. So you mark this point as P dash. And when you look from the top view, we can see the distance in front of VP. And when it is projected, that projected point will going to be on the vertical horizontal plane. So that distance is the 20 mm in front of VP. And you mark this point as small p. When these two are projected here, so you're going to get this as capital P. And similarly, the point Q is 20 mm above HP. So when you look from the front view, we can see the distance 20 mm above HP. That when it is projected onto the vertical plane, you are going to get this line as the locus of Q. You mark this as dash dot line. So this will going to be the locus of Q. And similarly, 50 mm in front of VP. So when you look from the top view, we can see the distance in front of VP. So this distance is 50 mm. So when it is looking from the top view, that is projected onto the horizontal plane. So you will going to get this dash dot line, which will going to be the locus of Q. And he says the top view of the line PQ is inclined at 30 degrees to XY line. So from P, when you draw a line inclined at 30 degrees, so that it will going to get the locus of Q in the top view. So you will going to mark this point as small q, then join P and Q with a dark line. As we know that the distance between the end projectors in the front view and top view will going to remain the same. So as we know this top view point, through Q you draw a vertical projector so that it will going to come here, and again from here you project this till here. So you mark this point as Q dash, then join P dash Q dash also with the dark line. And when you are projecting from Q dash and also from small q, both will going to intersect at this point. So this is the point, this is the line capital P and Q which is in space. Now this is how you will be able to get the front view and top view for this particular problem. So once you get that, now we need to find the true length in the vertical plane and as well as in the horizontal plane. With capital P and center, with P and Q as the radius in space, you rotated that line so that both capital P and capital Q1 are in front of VP by 20 mm, so that which will going to be the parallel to VP. Since it is parallel to VP, so you are getting the true length in VP. And when you are projecting this point, you will going to get directly here, which is P dash Q dash. How we can be able to see this rotation when you are considering on the horizontal plane? So when you are looking from the top view, as we are rotating capital P and Q in space, what happens to be image? The image is also being getting rotated. So with P as center, taking the radius of PQ, you make it parallel such that both P and Q1 are in front of VP by 20 mm. So now the top view line PQ1 is the line which is parallel to VP. So correspondingly in the front view, you will going to get the true length. So from Q1, you draw a vertical projector till here, and from here you draw a vertical projector till it touches the locus of Q in the top view and the front view. You mark this point as Q1 dash, then join P dash Q1 dash with a little bit thicker than the XY line, and you mark this point as Q1 because as the top view line becomes parallel, so it's correspondingly in the front view, you are going to get the true length. So that is also, it is quite evident here, both P and Q1 are parallel to VP. Similarly, if you want to find the true length in the horizontal plane, with capital P as center, taking the radius of PQ, you rotate it such that both P and Q2 are above HP by 40 mm. So now the line is parallel to HP. Since the line is parallel to HP, so you can find the true length in HP. Where is HP? HP is below XY line. So from, that means the top view. So from top view, when you project this Q2, it will going to cut the locus of Q here, so that you will going to get P and Q2. So this is the line which is the true length. So as we are seeing in the space, what happens to the image? with P dash as center, taking the radius of P dash Q2, P dash Q dash, you draw an arc such that both P dash and Q2 dash are above HP by 40 mm. Now the line is parallel to HP. So when you are projecting this, it will come here, and then from here, when you are projecting to the top view, so that it will going to cut the locus of Q in the top view, and you mark this point as Q2, then join P and Q2 with little bit thicker than the XY line. So now this line will going to be the true length line. So this is how we can analyze this problem in 3D. Now when you want to analyze it into stepwise, so you consider the line P and Q, which is the line which is in space. You rotate this and you make it parallel, that is P and Q1 is made parallel. So that means the image is also getting rotated here. PQ1 is the line which is parallel, and when you are looking from the front view, this line is been projected here, so you're going to get this Q1 here. So this is the line which is going to be in the true length. So when you are trying to see as an image, so when you look from the top view, this is the line of projection, and when you look from the front view, this projection is being projected here, so that you will going to get the locus of Q. So you are going to get Q dash or Q1 dash, then join P dash Q1 dash. Similarly, as we are seeing here, the top view line is made parallel, so both P and Q1 is in front of EP by 20 mm, and from Q1 you draw a vertical projector so that it will going to cut the locus of Q in the front view, and you mark this point as Q1 dash. Then this will going to be capital P and this will going to be capital Q. So you have P dash Q1 dash. Similarly, when you are trying to find out the true length in the horizontal plane, you take again the line in space, you rotate it such that both P and Q2 are above HP by 40 mm. So when you are doing that, what happens in the image also getting rotated, both P dash Q2 dash are above HP by 40 mm, and when you are projecting it to the top view, you will going to get that PQ2 is the line which is in the true length. So as we are projecting this, what happens? So from here, the top, the front view, the projection has been done here. As we look from the top view, so this is the line of projection. So that line of projection will come here, so that it will going to cut the locus of Q in the top view. So this will going to be small PQ2. Similarly, your front view line is made parallel, so that both P dash and Q2 dash is parallel to XY. And when you are projecting this to the locus of Q in the top view, you are going to get Q2, then join P and Q2 with little bit thicker than the XY line. So this is how you will be able to analyze this problem in 3D and as well as in the orthographic view by stepwise. Now we will try to solve this problem using the sketchbook. So to do that, first we will going to draw the XY line, then mark VP and HP. So by using so from XY line you measure 40 mm and draw a horizontal line. Similarly, above XY line. Similarly, from XY line you measure 20 mm below the XY line and draw a horizontal line. So consider any point and you mark this point as P dash, and from here you draw a vertical projector to the top view and you mark this point as small p, and here as capital P, and here as also as capital P. Then from XY line you measure 20 mm above XY line and draw a horizontal dashed out line, and you mark this line as locus of Q in the front view. And from XY line you measure 50 mm below XY line and draw a horizontal dashed out line, and you mark this as locus of Q in the top view. So once you get the end projector P, now we know top view of the line PQ is inclined to 30 degrees to XY line. So by using the protractor with P as center, measure an angle of 30 degrees and draw an inclined line such that it will going to cut the locus of Q in the top view, and you mark this point as small q. Then join P and Q with a dark line. Then as we know the locus of Q in the front view, from small q you draw a vertical projector so that it will going to cut the locus of Q in the front view, and you mark this point as small q dash. Then join P dash and Q dash with a dark line. Now we need to find out the true length in the vertical plane by using the compass with P as center, taking the radius of PQ, draw an arc such that both P and Q1 are parallel to XY line in the top view. That means P and Q1 should be in front of VP, that is Q1 is also below XY line by 20 mm. Then you mark this point as small p and Q1. Then from Q1 you draw a vertical projector to the front view such that it will going to cut the locus of Q in the front view, and you mark this point as Q1 dash. As we know that the top view line is parallel, its corresponding front view will going to be in the true length, and you mark this point as capital Q. Then join P dash Q1 dash with little bit thicker than the XY line. Similarly, with P dash as center, taking the radius of P dash Q dash by using the compass to draw an arc such that both P dash and Q2 dash will become parallel to XY line. That is, P dash and Q2 dash both are 40 mm from the XY line. Now the line is parallel. From Q2 dash, you draw a vertical projector such that it will going to cut the locus of Q in the top view, and you mark this point as Q2, and here you mark this as capital Q. Then join P and Q2 with little bit thicker than the XY line. So this is how, and you show the dimensions as is as shown, and this is how you will be able to draw the solution by using the sketchbook. Thank you.